Dr. Maya Dunne here. This is the chapter 1. I'm planning to give an introduction to chapter 1 and see what are the important concepts in chapter 1. We started um, chapter 1 with the scientific method, and then we are going to go for the measurements, and then the units, and then the prefixes and suffixes, and then we're going to talk about temperature, like I told you, the units and the instruments. What are the units you need to measure the temperature? And then we talk about uncertainty and the significant figures. And then unit conversions, accuracy, precision. And then the last part is classification of matter. So chemistry, it's very important you know about the scientific method. Always, as the it's a scientific method is how a scientist look at a problem. It's without bias. Always when we see an issue, we have to formulate an hypothesis, and then by looking at observation, we formulate hypothesis, and in order to prove the hypothesis, whether it's right or wrong, we need to do some experiments. And then from these experiments, we formulate theories, and then this further experimentation will prove the laws. In scientific measurements, it's very important. In as a chemist, we are taking the measurements two types: quantitative, qualitative. Qualitative is like there's no number. Like I take water, like it's you said, okay, water is no color, water doesn't have a color. And then like you compare the two water containers, you say, oh, this has bigger amount of water. But qualitative is more specific and more accurate. Sorry, quantitative. It use the units and the numbers to express it. I'm saying, okay, I have 5 milliliters of water, I have 100 milliliters of water. So that is quantitative measurement. Always the metric system, metric units include, like, these are the metric international units, length. Maybe I can ask a simple question in the exam. What are the SI units for um, to measure the length? So it's meters. For mass, it's kilograms times seconds. It goes like that. Temperature is important. We take so many temperatures throughout the in chemistry labs. We usually use Celsius, and then but in the formulas we use Kelvin temperature. Uppercase K stand for Kelvin. You need to know, it's very important how to convert Celsius to Kelvin. Always, if Celsius 30, you add 273 degrees to the Celsius temperature and it convert to Kelvin. Density is the substance in the ratio mass to volume. Density measured by, it's given here, mass divided by volume. Always density, mass divided by volume. And then if you move to the concept uncertainty, there are two types of numbers. You can measure um, like 15 meters, or else you can say, okay, 15.23. So how would, like, the last digits, most of the time when you take a measurement, we say the last digit is uncertain. But if it is exact number, okay, it's 12, is it 12 eggs, that's no uncertainty, there's 12 eggs. But when there is not an exact number, then the uncertainty comes. Most of the time when we get the measurement, we say, okay, my height is 5.4, 5.4, like that. So the length measurements, mass measurement, for those kind of measurements, a lot of scientific measurements, we get uncertainty. And then if you see this one, this ruler, 2.5, this measurement, 2 points of, they measure the width of the flash disk. 2.5, I can say 2.5, and one of you can say, oh, it's 2.4. Another person can say it's 2.6. So in that way, the 0.5 is uncertain. And but this one, let's see. So, but if you think about this, it says, okay, 2.45. This is like very accurate. 2.45. You say 2.45, I say 2.46, some other person say 2.44. So that means the last digit always uncertain. And then I'm going to these significant figures, very important. Mainly I did this video to explain you about the significant figures, significant numbers. There are certain rules we can use to assign significant numbers. The rules are any non-zero digit in a number is significant. Example 112.1 for Sig Figs. Zeros between non-zero digits are significant. 305, this is zero, right? But it's significant because it's between non-zero digits. 50.08 for Sig Figs. Zeros to the left of the first non-zero digits. If it is towards the left, it is non-significant. So it's important. So this has two Sig Figs. This is one. This third rule is very important to know. And then the zeros to the right, it is significant. Zeros to the right of the last non-zero digit in the number that does not contain a decimal point may or may not be significant. This way, if I ask you how many Sig Figs, write in a scientific notation. How to write in a scientific notation? Think about if it is like you write coefficient and 10 to the power. You write 1 in this way. So you use scientific notation to so you can write if it is given in 1 into 10 to the power 2, this has 1 Sig Fig. 1.0 into 10 to the power 2, it is 2 Sig Figs. It's like that. So this is how you say, okay, this is the significant number. So I have some practice problems. So 443, 3 Sig Figs, 4 Sig Figs. This is 3 because it's towards the left. This one, 3.000 into 10 to the power negative 7. Always, this is a coefficient. This is the 10 to the power. All the numbers in the coefficient is significant. 4 Sig Figs, 50. It can be 1 or 2 or ambiguous. Now you may have a problem. What is in the exam? Don't worry, it will not be confusing. I may give you in the scientific notation. Oh, it will not be confusing. That's what I can say. So this one, this is not significant, but these 4 numbers are significant. Also, I wanted to show what is the rule when you do the addition and subtraction. Very important to know. The rule in the Sig Figs for addition and subtraction, the answer cannot have more digits to the right of the decimal point than any of the original numbers. So these two has 2, this is 2.3231. So you need to give the answer to the 2 decimal points because this has only 2. This is give the 1 because cannot have more digits to the right of the decimal point any of the original. So original one has 1 decimal point. You give the answer to the 1 decimal point as well. Multiplication. So this rule we talk about for addition and subtraction. When you come to the multiplication and division, the number of Sig Figs in the final product or quotient is determined by the original number that has the smallest number. It doesn't talk about decimal point. It's take whole number and see how many decimal points in this one number, how many decimal points in the other number, which has the fewest decimal points, fewest Sig Figs you give. So give the answer. So this one has 2 Sig Figs, this one has 4 Sig Figs. You give the answer to the 2 Sig Figs because this number has lowest number of Sig Figs. In the same rule applies for the division, 4 Sig Figs, 5 Sig Figs, answer given to the 4 Sig Figs. So that is important. So we learn rules for significant numbers. What is the rule for addition? What is the rule for multiplication and division? So accuracy and precision is another thing. Accuracy is how close your measurement to the true value. Precision, when you take the series of data, how close each data to a to these each, like example, you measure something, measure a block. You said, okay, it's 10.1, 10.01, 10.02, 9.99. So that is very like precise because it's very repetitive. but it's accurate means if it is 12, the mass is 12. Okay, mass is close to the accurate number. And then dimensional analysis, conversion factors, like 1 inch is 2.5 centimeters. It's important. It's the same if it is 1 inch or 2.54 centimeters. It's the same thing. It's the same length you express in different units. How do you convert the unit is also important. I have some practice problems. You can practice it. And then if I help, sorry, if I explain this one, the Food and Drug Administration recommends the dietary sodium intake no more than 2,500 milligrams per day. So, so is it correct, or so? How do you do it? The conversion is how do you do? It's 2,400. So it's if milligram you convert into grams. How do you do it? 1 gram, 1,000 milligrams, and you convert into lbs. 1 lb is 453.6 grams. It's like 500, like very similar, like half of a kilogram equal to 1 lb. So that's how you need to convert. So you convert milligrams to grams, and then the grams to lbs. So you can convert in. So it's same. You said okay. Um, if you say um, dietary sodium 2,500 milligrams per day, or 0.005291 lbs per day. It's the same thing. So I hope this will help you to understand about this the chapter. It's very introductory chapter. If you have taken 1405, you may know many of these things, and hope this video help you to understand better. Thank you.